and today we're going to be looking at how can you estimate decimal sums and differences. So we're going to be estimating, adding, and subtracting of decimals. We're going to use two different methods. The first method that we're going to use is we are going to use rounding to help us to estimate. Here it says we have a singer recording a CD. The lengths of the three songs are 3 and 4/10 minutes, 2 and 78 hundredths, and 4 and 19 hundredths minutes. About how much total recording time will be on the CD. Now, when we're working with decimals and we're estimating their sums and differences, we aren't really worried too much about the actual decimal places. Right? I mean, if we really think about it, 19 hundredths of a minute is really not a whole lot of time at all. So we're going to round all of these to the nearest whole number or the nearest minute. Well, 3 and 4/10 is going to round down to 3. 2 and 78 hundredths is going to round up to 3, right? Because we are going to look at the 7 and it is greater than 5, so we would round that one up. And then over here, 4 and 19 hundredths, again, we're going to compare the 1 to 5. It's too small, so we're going to round that one down to 4. Then we're going to add these together. 3 plus 3 is 6, plus 4 is 10. So again, we're using rounding to estimate, and we're rounding to the nearest whole number when we're doing this. So we're going to look at about 10 minutes of music on this CD. So that's that. That's how we're going to round. Well, let's look at another one. We can take a look at that idea. Here, we're going to round it to the nearest dollar, and this happens very frequently in real life. When we go shopping, like if you go to the grocery store or any other place, and you're trying to keep track of how much money you're spending, you're not really adding together all of the pennies, right? You're not saying, oh, well, this is $3.25 and $2.50, right? You're going to round those numbers to the nearest dollar. So if we are finding the difference between $27.95 and $11.72, right? We're going to say, oh, well, $27.95 is about $28, $11.72, right? Again, we're looking at this number to the right of the whole number. 7 is greater than 5, so we're going to round it up to 12. Both of these numbers round up. And then we just subtract. 8 minus 2 is 6. 2 minus 1 is 1. So the difference between these two numbers is $16. Now, if we did the true math, right, 5 minus 2 is 3. 9 minus 7 is 2. 7 minus 1 is 6. 2 minus 1 is 1. Right here is the actual answer. The exact answer is $16.23. Right? And that's just really close to 16. We're really not going to worry too much about those 23 cents. So that's rounding to our nearest whole number to subtract. Another way, oops, don't want to delete that. Another way that we can use rounding or estimating when we're dealing with decimals is, let's say that we have two or three numbers, right? We'll just say that we have these three numbers. Now we can use what we call front end estimation, and basically what that means is that we take these decimal pieces and we're just going to ignore them. They're really not going to account for very much. We'll be off by 1 or 2, but again, if our objective is just to get an idea about something, then we can just look at our whole number. Right? We can ignore the decimal place altogether, and we can say, oh, well, 3 plus 2 is 5, plus 4 is 9. The actual answer here is going to be like, 10 and 13 hundredths, I think. So again, super duper close. So rounding, front end estimation. And then the next one, which is a little bit trickier, but gives us a much more exact estimate, is we can use benchmarks to estimate. Our benchmarks are 0, 25 hundredths, 5 tenths, 75 hundredths, and 1. And hopefully when we see these numbers, we're kind of thinking about like money, right? Because if we have 1/4, then we have 25 cents. If we have 2 quarters, we have 50 cents. 3 quarters is 75 cents. And then, of course, 4 quarters is 1. So we can use these benchmarks to help us to get a more exact estimate, right? Especially when we're working with numbers that are already really, really small. So the way that we're going to do this is if we're looking at 1800ths plus 4300ths, right? We're going to think to ourselves, well, which of these benchmarks, right? And I forgot to put 1 and 0 on here, right? But which of these benchmarks is 1800ths closest to? Well, if we use a number line, it's pretty easy to see that it is closest to 2500ths, right? So I'm going to put in 2500ths and then 4300ths. So if I put that out here, right, this is 3/10, 3500ths, 4/10. So 4300ths is going to be about right there, right? So 4300ths is closest to 5/10. So 2500ths plus 5/10, right? Or we think of it as like 1 quarter plus 2 quarters, and that is going to equal 7500ths or 3 quarters. Right, so we can use these benchmarks to help us to estimate our addition when we're working with really small numbers. We'll look at another one. We'll use a number line again to help us with this one. So just like we did it with addition, we can do the same with subtraction. I'm going to start by plotting 7600ths on my number line. It's going to be right about there, right? So I'm going to say that that one is obviously closest to 7500ths. And then 2200ths is going to be about right there, which is obviously closest to 2500ths. And so if I have 7500ths minus 2500ths, or 3 quarters minus 1 quarter, I'm going to be left with 2 quarters, which is worth 5/10 or 50/100, right? Because 5 minus 5 is 0, 7 minus 2 is 5. So that would be my estimate. Let's take a look at a couple of problems here. And it says that they want us to use benchmarks to estimate, but we're going to use, let's start with this one. And let's just use, I have to grab this thing and bring it over, right? So we're going to use estimating to do this one, right? So we're going to ignore those rules, and we're going to estimate using rounding. Each of these numbers is a 4 in the 10th place. That means that they're both going to round down. So I'm just going to cross out the decimal. 12 minus 6 is 6, right? We take a look at the next one here, right? We're going to actually use our benchmarks. Now, 1200ths compared to our benchmarks. Remember, our benchmarks are 0, 2500ths, 5/10, 7500ths, and 1. Well, 1200ths falls somewhere in here. And it's really exactly in the middle, right? Or as close to the middle as you can get, right? It's 1200ths away from 0, and it's 1300ths away from 25. So it's really like close to those two. So you could choose either 0 or 2500ths. I'm going to go ahead and call it 2500ths. Now, 5200ths, right, is going to be between 5/10 and 7500ths, but it's clear that this one is closest to 5/10. Now I'm ready to add, right? 5 minus 0 is 5. 5 minus 0. 5 plus 0 is 5. 2 plus 5 is 7. Don't ever forget your decimal. That is always really, really important. And 8 plus 5 is 13. All right, we're going to do one final problem, and then that will be it for this lesson. Let's see if we can get this over here. All right, so here we have 9 and 7500ths. Well, 75/100 is a benchmark, so I don't need to change that one at all. Minus 3 and 47/100. Well, 47/100 is really close to 50/100 or to 5/10. So I'm going to change this one to that, right? And now I'm ready to subtract. I'm going to go place by place. 5 minus 0 is 5. 7 minus 5 is 2. Always make sure that we bring our decimal point down and put it in our answer. And then 9 minus 3 is 6. So our estimate using benchmarks for this problem is 6 and 25/100. All right, that's lesson 3.7. We're going to round or use benchmarks to estimate throughout this lesson. Rounding should be pretty straightforward and easy. Benchmarks, again, remember these are them: 0, 25/100, 5/10, 75/100, and 1. Give the problems in your book a try and let me know if you have any questions.